Good Friday morning, Backyard Naturalist friends. It is July 18th, 2025. My name is Tim, and I will be today's host for another edition of the Urban Ecology Center's Backyard Naturalist. Uh, when I reflect back, as I was reflecting with you over the 300 plus episodes we've done over the years, we haven't done a lot with fish. I don't think I've ever done a fish episode, and this could be because we learned that fish don't exist, or it could be that what we call fish don't usually exist in our backyards. Usually, sometimes in our houses. We have had some great fish episodes, sturgeon, salmon. We had I think our only guest cooking demonstration on fish. Um, so as we wind down towards the season finale, I thought it would be fun to do a fish-based episode. Um, and I thought it would be fun to talk about this fish, which in recent memory uh, had some news 20 years ago. And this fish just has some just strange and wonderful and weird stories with a name that's hard to see and spell. I was going to go back to call this the old man and the coelacanth, but then that would be I just literally just did the old man and the sea monkey. I also had the old man of war in the sea, so I couldn't, in good faith, give you the old man and the coelacanth. But all the light we cannot coelacanth. Um, I hope you can sit back and relax and enjoy from the warm glow of your device, episode 41 of season 6 of the Backyard Naturalist, which is again all the night we cannot see coelacanth. As ever, I'm so grateful that you're all here with me today, whether you're here live or watching this recorded version of me in the future. I'm so glad you're here. Honored to be spending time with you, and especially grateful for this subscribing community. Some of you have been with us since the very beginning in 2020 for season 1, episode 1. So thank you, thank you, thank you. We are also a couple of weeks away from the end of the Green Spaces season, and we have a golden trifecta of awesomeness starting on August 2nd, when Emily Helm and Jen Hensey will give you a tour of the natural areas of Washington Park and all the great work that they've been doing there. That's a 9 a.m. start. Then the following week on August 9th, I'll be leading a delayed stroll through one of my absolutely favorite green spaces anywhere in Milwaukee, Cudahy Woods State Natural Area. That'll be at 1 p.m. And then finally on August 16th, also at 9 a.m., we'll head down to Doctors Park with geologist Bill Keene, just another wonderful, wonderful teacher. He just makes the story of geology so accessible and digestible, and it's really cool. Um, I would also love for you to join Amanda and myself tomorrow at Washington Park for our beginning birding class. Um, it's like I said, birding is a community of learning, and so no matter your skill level, I think it'd be fun for you to show up. I guarantee you'll learn something. Whatever you consider yourself as a birder, I hope you can make it. And we will also run it again in August at Riverside Park if you can't make it tomorrow, or even if you can make tomorrow, come back in August at Riverside Park. And the same can be said for our Becoming a Better Birder series, which continues on August 7th at Riverside Park. Birders of, again, all skill and experience levels are welcome and encouraged to attend. I also need to shout out a few of the favorite regular sources of information for most of these episodes lately, in particular, the Backyard Naturalist, so the Stuff You Should Know podcast, probably the best podcast in history, maybe after the Bird Joy podcast, and then How Stuff Works website and the Mental Floss website, providing me with hours and hours of learning over the past couple of decades for sure. So today we are talking about a fish, and I'm going to use the word fish, even though there's no such thing as a fish, in the same way I talk about vegetables, even though there's no such thing as a vegetable. So today we're going to call it a fish. Everybody knows what you mean generally. And even before we talk about the fish itself, we do have a connection, a very strong connection, probably not with your backyard, but with the backyard of one of the urban ecology centers. So we'll go to, you may have seen this landmark at Riverside Park. There's this little pile of rocks, this cairn off of Park Place, just past the new event hall. And this is the first stop in the 3 billion year walk. And so as you walk towards the river, the cairns get progressively older. So this is the youngest one. Um, this is Devonian dolomite, and these rocks were quarried very locally, right off of Capitol Drive in what's now the UWM parking lot just west of the Milwaukee River. Um, when these rocks were formed, which you can visit and touch and smell, um, our planet was in the midst of what we call the age of the fish. So they were the dominant life form on the planet, having spread throughout the oceans. They were joined by other things, trilobites and other organisms, but fish were the dominant life form. At the same time, and by this time, on land, an atmosphere had developed because the land had been colonized by plants, not flowering plants yet, but other kinds of plants, algae, things like club mosses, fungi, not technically plants, but vegetative matter. So, and by the time those rocks were formed, there were already forests. They just weren't forests of trees. They were forests of club mosses and fungi and ferns, huge ferns and mushrooms and horsetails. And then you had all the other plant forms that were creating the first stable soils, so that the plants were really developing rapidly. You already had animals on land, mostly arthropods, mites, scorpions, insects. So you can imagine at this time hiking through these ancient forests as the oxygen's building up that allows us to survive. And you're looking up at mushrooms towering 50 feet, over you. These huge plants, these huge uh, the mosses, the clubtails. For the home team, this is what it looks like. What we think it would have looked like going through these ancient forests of not trees. But then for the home team, this is Prototaxides milwaukeeensis. So this is a large fungus that stood over 26 feet tall that is named after our hometown here in Milwaukee. Um, and if you've been to the Third Planet exhibit at the Milwaukee Public Museum, you may have seen this giant dragonfly that was sitting atop what looks like a tree, but again is really a club moss. So that's what it looked like when those rocks were forming. You had the fish dominating the sea. You had this terrestrial habitat that was ripe for colonization by these larger animals. And then you start to get the migration, the movement of these fish-like creatures to the land and the evolution of what were amphibian-like creatures, fish-like creatures to amphibian-like creatures. And one of the groups of fishes that was thought to be part of that evolutionary movement was the coelacanths. At the time they were swimming, and over the next 330 million years, as they swam with the dinosaurs that came and went, they watched pterosaurs flying overhead. They swam with megalodons and mosasaurs. There were over 100 species of coelacanths, large, small, fast, slow, uh, all likely predators. There was a 10-foot long toothless specimen, and that was called Megalocoelacanthus, and there was a 16.5-foot specimen called Mawsonia. Again, predator, could likely easily eat a human. But then, about 80 million years ago, they completely disappeared from the fossil record. So nothing after that. So paleontologists assume this was just another group of animals that lived and thrived and radiated and adapted and then died out. There's a lot of those. That's the case for most life forms. So that was, going to be the kind of ending book on the coelacanth. Then fast forward to December 23rd, 1938, and this is where the human story starts around the coelacanth. It starts with an ordinary, I don't know if he was ordinary or not, a fishing captain, Captain Hendrik Goosen, who took out his fishing trawler, the Nareen, out near the mouth of the Chalumna River in South Africa, and got his catch, brought it back, And the one thing that he always did when he brought his fish catch back is that he called a friend of his, a woman by the name of Marjorie Courtney Latimer. She was the curator of a small local museum in East London, South Africa, and just, really loved fish. And so they had a little relationship where he would bring his fish catch and she would kind of look over what they had to see if there were any good specimens for the museum. So on this particular day, Captain Goosen's, you know, does his thing, gets his catch, brings it back. He calls her like he usually does, and apparently she had no intention of heading over there um, to review the fish because it was December 23rd and it was, Christmas time. She wanted a break. She decides to go anyway, not not really because she wants to look at the fish this time, but she wants to wish the captain and his crew a Merry Christmas. So kind of out of that kindness gesture, she goes out there, but of course she looks through the bycatch anyway. Then Marjorie can tell the story in her own words. She says, quote, I picked away the layers of slime to reveal the most beautiful fish I've ever seen. It was 5 foot long, pale mauvey blue with faint flecks of whitish spots. It had an iridescent silver blue-green sheen and was covered in hard scales. It had 4 limb-like fins and a strange little puppy dog tail. It was such a beautiful fish, more like a big china ornament, but I didn't know what it was. So, at this point, Marjorie does what any of us would probably do. She convinces a local cab driver to put this 5 foot long, 127-pound fish in the back seat of their cab, takes it back to her museum in East London. And so now she's got this huge fish in her lab, and now she needs to preserve it. So she has a taxidermist prepare a mount. Unfortunately, the taxidermist and wasn't, probably aware of what they needed to do for this fish, but he disposed of the skeleton and the gills and the guts, which would have been really important. But now she has a mount. And then the next thing she does is she makes a sketch of it and sends the sketch with a letter to J.L.B. Smith, who's the head of ichthyology at Rhodes University in Grahamstown. Now the story continues in his words. I told myself sternly not to be a fool, but there was something about that sketch that seized upon my imagination and told me that this is something very far beyond the usual run of fishes in our seas. So he immediately responds with all caps, most important, preserve skeleton and gills to describe the fish. Well, of course, the taxidermist had already gotten rid of those. He flies to East London to look at the fish. He and Marjorie, with the help of some preserved scales, are able to identify the fish, not from a fishing guide or a zoology textbook, but from the fossil record. So that's when they realized they had a coelacanth, which again was thought to be extinct for more than 80 million years. So the trawling captain, Marjorie, JB together found what might be the most amazing discovery of this kind, certainly in the 20th century, but maybe, I don't know how you rank these. But, this was all because she really just wanted to go and wish this crew a happy Christmas. JLB Smith is quoted as saying, if I'd met a dinosaur in the street, I wouldn't have been more astonished. So as the scientist in the crew, the male scientist, he names the fish, but he names it Latimeria chelumnae. So Latimer for Marjorie Latimer and Chelumnae for the Chelumna River in South Africa, where Captain Goosen caught the specimen. So over the next 60 years, a few more specimens are caught. JLB Smith, all of a sudden, like this was his new thing, was to really determine, are there more? He finally catches another specimen. And again, over the next 60 years, occasionally a specimen is caught. And then in 1997, and I remember this, a biologist by the name of Mark Erdman, he discovers another coelacanth in an Indonesian fresh fish market. A year later, after trying pretty hard, he catches a fresh specimen. It's smaller than the other coelacanth. It's browner in color, and it turns out to be a new species. So now a fish thought to be extinct for 80 million years not only did they find it, but now there's at least two extant species living among us. So I guess the first kind of biggest question is, why did this fish completely drop out of the fossil record for 80 million years? And there's not a definitive answer, but it's thought that, like many groups of animals, there probably was a mass die-off. Most 90-some% of the coelacanths did probably go extinct. But the few species that did make it, it could have been just that they were in areas where conditions weren't conducive to fossil formation. If they were kind of these relics, these kind of survivors, they might have survived because they were in a pretty isolated condition or area. And if it's where they are today, it's mostly volcanic rock activity, and they're in caves, and there's not that sedimentary deposition that is important for fossil information. So it could be that just you had a few survivors and there are no fossils because they weren't being formed into fossils. And for quite a while, biologists and paleontologists thought that the coelacanth represented this really important missing link between the fish of the Devonian and the tetrapods that colonized the land. Um, when Marjorie Courtney Latimer described the fish, she noticed that four of the fins looked a lot like the arms and legs of the future land dwellers. They just looked like they should be arms and legs. They still had all those fins, and the front fins in particular were attached to a bone that is very similar, analogous to the humerus bone in humans. So for a long time, it was thought this is it. This is the missing link between fish and land dwellers, amphibians. Um, but of course, we do have other tools at our disposal, other genetic tools, and the modern genome says no, this is not actually the case. The coelacanth is its own branch that has just survived independently. It's not likely the fish that led to um, modern animals, including humans. Um, the more likely candidate for that is the lungfish. Um, that this is the lungfish and the relatives, that branch of the tree. Um, but the coelacanth is a pretty close cousin, pretty closely related to the lungfish. And so some crazy adaptations that support this theory of movement to the land. And so we'll we're still living with them, and we'll take a closer look again at the two extant species. So the original species that Courtney Latimer found is known as the West Indian Ocean coelacanth. Any one of us could, in theory, go and swim with this fish that also swam with the dinosaurs. It's also called the African coelacanth, or sometimes just the coelacanth because it was the original. Locally, it's known as gambessa, especially among fisher folks. And the highest concentration of these today are around the Comoro Islands, Madagascar, Mozambique. Numbers probably in the hundreds, maybe 1,000 or more, so not super common, but as a long-lived fish, there there's more than one. The species that was found more recently by Erdmann is known as the Indonesian coelacanth, or sometimes the Sulawesi coelacanth. So a little smaller, a little browner in color, but still looks like it's still got that puppy dog tail, looks like it's ready to just climb up on the land. And for the most part, they're cave dwellers, which again might be one of the explanations how they were able to survive in relative protection while most of their relatives went extinct. During the day, they for the most part hang out in these caves with 15 to 20 other coelacanths, and then at night they come out of the caves to hunt. They're nocturnal predators. Their primary prey is the cephalopods like the cuttlefish and the squids. They will eat other fish. Um, Usually they're passive hunters, waiting for the prey to come to them. So kind of sit and wait, or for the currents to bring the prey to them. That wasn't the case certainly for their relatives, hundreds of million years ago. There were certainly faster, stronger, probably chasing type predators. But the two species we know of today are sit and wait predators. They can be found as deep as 2,000 feet, but mostly they hang out between 500 and 800 feet, primarily likely because that is the area where we call the twilight zone. So it's below the kind of lighted zone where a lot of fish live. It's above the dark zone where a lot of fish live. They're kind of in that twilight area. Um, they have a what's called a rostral organ in their nasal region that's filled with a jelly-like substance. And there's kind of two sides to it, like a battery, and it detects low-level electrical signals and frequencies. So it's an electrosensory organ, like a electric eel, like sharks and rays have something similar that allows them to detect living tissue, because when living tissue is in water, it creates electrical impulses that can be picked up by either equipment or animals. And sometimes the coelacanths have this habit of swimming nose down, like they're doing a headstand for 2 minutes or more. I will neither confirm nor deny that I just took a regular coelacanth picture and rotated it to looks like, so it just looks like it's doing this. But the thought is that they're when they do this, they're using that rostral organ to sense for prey. They're just kind of concentrating all their energy and trying to detect where the electrical impulses of potential prey might be located, I would imagine. And there's a kind of like we have 2 ears, 2 eyes. It helps sense direction, things like that. Um, they're pretty effective predators. And like snakes and gulls that I learned from Amanda, can they can eat prey that is much bigger because there's a hinge in their cranium and it allows the top of their skull to retract, which means they can open their mouth much wider. And the interesting thing with the mechanics of the coelacanths that I'm not sure is the case with snakes is that the same mechanisms that allow them to do this also allow them to close their mouth with much greater force than they would if it was just more of a traditional jawbone. So pretty good predators for the last 400 million years. The name coelacanth means hollow spine, and they do indeed have a hollow what's called a notochord, which is hollow and it's filled with oil like a hydraulic system that's pressurized. And this is interesting because other fish start with a notochord, and other animals do, including humans. So early embryonic development in humans, we also have a notochord instead of a spinal cord. And ours and most fish, though, this notochord is replaced with bone to create our spine. In the coelacanth, it never develops beyond the notochord. So again, it's kind of when you're looking at piecing together this evolution, this could be a step that kind of represents that early move onto the land, or just a regular evolutionary development. And there was just not the pressure on the coelacanths that there were on other fish or land dwellers. Even further and crazier is that early on in development and gestation, coelacanths they develop lungs. They don't completely develop into lungs. In fact, the development of the lungs slows down and stops before they can become functional. So the adult coelacanths just kind of carry around these vestigial lungs that serve no purpose that we're aware of, maybe similar to our appendix or something like that. But again, more evolutionary evidence as we're piecing together what happened. So their notochord doesn't develop, but they do develop lungs, but the lungs don't continue to develop. It's really fascinating and make this a really fun area of study. I think there's a new Netflix series on where folks are using birds to help solve crimes. I think there should be something with this evolutionary aspects of the coelacanths to do this as well. There's still a lot we don't know, including how reproduction takes place. We have yet to confirm that male coelacanths even we have yet to find reproductive parts in male coelacanths. So it's possible that they only form when they're needed. Maybe there's something that happens delaying things or preserving sperm somehow. Anyway, we do know that they're ovoviviparous, which means that the eggs however they're fertilized, develop inside the female, hatch inside the female, and then continue to develop inside the female for quite a while, up to 3 years before they're born as live baby fish. When the live baby fish are born, the first thing that they do right away is they dive down to the depths as quickly as possible, probably to get away from mom because mom will eat her own young, probably because she's sick and tired of having hosted those little parasites for 3 years inside of her. But they immediately dive down and start growing into bigger coelacanths. And um, it's also thought that they're monogamous, which would be pretty rare for fish, and that might be because maybe I don't know, maybe they only mate once. This is totally me speculating. Maybe they only mate once and they have enough sperm for their life, which would make them monogamous if they only mate once. So again, just a ton we don't know, partly because it's such a rare fish, hard to find and study for sure in the wild. And all of this leads to the question that I'm sure you're all asking. Eric in particular, I'm sure, is asking this. Uh, do they taste good? Would I want them on my dinner plate? Apparently, and sorry to disappoint, uh, they taste pretty gross. In fact, their tissue can make you a little sick because it's full of urea oil. It's full of things called wax esters, very fatty. And a weird fact is that inside their skull, the brain only occupies 1.5% of the area of the skull. 1.5% brain, 98.5% fat in their skull. No idea why, what that means. But just remember, these fish are pretty darn successful. So, say what you want. They've been around for 400 million years. If any of you are fans of anime and Ghibli Studios, apparently in this scene from Spirited Away, an animator did in fact reveal that that strange shaped food that circled at the bottom in this scene was coelacanth. So there's one of your pop culture coelacanth references. Also, apparently in 1975, a prominent hematologist, Charles Reed from Long Island University, wrote an operetta called A Coelacanth's Lament, aka Quintuplets at 50 Fathoms Can Be Fun, apparently sung to the tune of various Gilbert and Sullivan songs. I could not find it anywhere to share with you, so maybe you're better at looking for it and you can find it and share it with me. But I guess for now we will just have to imagine that. So the coelacanth tells an absolutely fascinating story, not only how it was discovered, after thought to be extinct for 80 million years, but also in how it represents this early group of fish that attempted to colonize the land with an atmosphere. And I mentioned they're related to the lungfish, which has the most support for being that missing link. But it's pretty crazy that they've been around for 400 million years. So it makes them kind of a living fossil. They swam with dinosaurs, and we can swim with them. And the fish in general, or this group we know of as fish, do a pretty good job of giving us more of these living fossils. We talk about how turtles have remained unchanged for a long time. Um, there's quite a few fish still around today that are probably very little changed from when they were swimming with dinosaurs, actually before dinosaurs. Um, and so it's pretty cool that today we still have fish that we can hang out with and marvel at, um, that saw those well, I mean, their ancestors saw the the creatures that we can only imagine in movies for now. So there's a few more examples, and some of them are closer to home. One of them is the bowfin or the dogfish or the mudfish, sometimes known as grindle, which we can find here in the Great Lakes and other parts of the U.S. We don't have to go very far. These guys are these fish are crazy aggressive apparently, and will eat just about anything that's around: small mammals, snakes, frogs, other fish, um, and we have them here. We also have here in Wisconsin another fish that swam with the dinosaurs, the gars. Particularly here is the long-nosed gar, also very aggressive. So I don't know. It seems like maybe between the gars and the dogfish and the coelacanths, which are also pretty aggressive predators, maybe that's one of the reasons they're still around. Um, but this is the garfish are known for killing prey that they won't eat. So kind of like out of spite. Probably humans are the only thing, or I'm sure there's other creatures that do this, but including humans, that will kill things that they don't need to eat. That's pretty rare, but the garfish is one of them. If you ever see long-nosed gar caviar on a menu, please don't eat it because the eggs are toxic to humans and will likely kill you. There's also the hagfish, which to me is straight out of an H.P. Lovecraft novel or Dune or Stranger Things or something. Maybe subjectively not super pleasant to look at, and also the fact that they don't eat prey like most self-respecting fish do. They from the outside, they actually go inside and eat the prey from the inside out. Again, with the H.P. Lovecraft or the maybe Stephen King or something. Um, then there's a much more familiar living fossil to us, particularly here in Wisconsin, which are the sturgeon. We've got the lake sturgeon here. This was the other top candidate to be the focus of today's episode. It was between coelacanths and sturgeon. Um, so lake sturgeon here in Wisconsin have a long history socially, evolutionarily. There are sturgeon all over the world, including ours, both in fresh and salt water, that are known in many parts of the world for their caviar. Um, they they can live 150 years or more. They can reach 20 feet long. I think some species don't even reproduce till they're 50, 60, 70 years old. Um, and coelacanths too live a long time, which is good for their own species protection. They can likely live over 100 years. So um, that's the coelacanth. Super cool, amazing survivor. Pretty unbelievable that they're still here with us today, that we found them again. Um, like many fish threatened by overfishing, threatened by climate change, that would be a pretty awful end to their story if they survive for 400 million years, but then, we get rid of them overnight for dumb reasons. So hopefully that doesn't happen, but tells a good story. I'm glad they're still with us. I'm glad you're still with us. And I think that will be the end, and I will stop sharing my screen. And we'll see you next week.